Hello, hello, hello. Good morning, everyone. Mega love shout out to all the subscribers and followers of this channel. And if you are new to my channel, please subscribe to like, share. Don't forget to ring the bell buttons for the next notification. 3, like, leave a comment, subscribe. 4, subscribe. Alright. Our lesson for today is writing a proof in geometry, and this is Mathematics 8, Week 6, and this is your teacher, Marife Adonis. Okay, so we have geometric proof. Our objectives: write two-column proofs, prove geometric theorems by using deductive reasoning that uses facts as rules and the definitions to make conjectures from given situation. Okay, so let's have this. We will discuss some vocabulary here. A theorem is a statement that can be proven true. So throughout our proving, we will use theorems. Okay. Two-column proof is a format for proofs where the statements are listed on the left and the reasons are listed on the right. Okay, when writing a proof, it is important to justify its logical step with a reason. You can use symbols and abbreviations, but they must be clear enough so that anyone who reads your proof will understand them. Okay, so we have definitions, postulates, properties, and theorems. And it's used for making hypotheses and to make a clear conclusion. Okay. The proof is a logical argument in which each statement you make is backed up by a statement that is accepted as true. One type is called a paragraph or an informal proof. In this type of proof, you write a paragraph to explain why a conjecture for a given situation is true. In constructing a proof, it must include the following 5 essential components. So first, statement of the theorem to be proven. Of course, there's our statements, okay. 2, list of the given information. It is needed. A diagram to picture the given information, okay. And a statement of what is to be proven. And then proof consisting of statements and reasons. So these are 5 essential components in constructing a proof. Okay, the formal proof is written in the following format. So first we have the theorem or the statement to be proven. Then the given, that is your hypothesis, and prove your conclusion. Okay, and this one, it just look like this, no? So we have a proof. So in a proof, we have the statements, and the second row is the reasons. Okay, so here are key concepts. The properties of real numbers, of course. The following properties are true for any numbers a, b, and c. So addition property of equality, of course, if a equals b, then a plus c is equals to b plus c. For subtraction property of equality, if A is equals to B, then A minus C is equals to B minus C. For multiplication property of equality, if A is equals to B, then A times C is equals to B times C. For division property of equality, if A is equals to B, then C is not equals to 0, then AB is equals to B over C. For reflexive property of equality, A is equals to A. So it's a reflexive, we call it as a mirror. No? For symmetric property of equality, if AN is equals to B, then B is equals to A. For transitive property of equality, if A is equals to B and B is equals to C, then A is equals to C. Substitution property of equality, if A is equals to B, then A may be replaced by B in any equation or expression. For distributive property, A close and open parenthesis B plus C is equals to AB plus BC. So these properties are very important in proving your statements. Okay. Next, so we have theorem. These are complement of the same angle congruent. Okay, let's see. We write the theorem in if-then form. Okay, so if two angles are complement of the same angle, the two angles are congruent. Yes. Given angle 2 and angle 1 are complementary. So two complementary angles, their total sum is equals to 90 degrees. That's why they complement. And angle 3 and angle 1 are complementary. So both angle 2 and angle 1 are complementary, and angle 1 is and angle 3 and angle 1 are also complementary. So let us prove that angle 2 is congruent to angle 3. Okay, so we have angle 1 and angle 2 here. So proof. Okay, so from first statements, angle 1 and angle 2 and angle 1 are complementary. Then angle 3 and angle 1 are complementary. So of course our reason is given. Huh? From measure angle 2 plus measure angle 1 is equal to 90 degrees, and measure angle 3 plus measure angle 1 is equal to 90 degrees. So our reason is from the definition of complementary angles that says two angles are complementary if their total sum is 90 degrees. Okay? So measure angle 2 plus measure angle 1 is equal to measure angle 3 plus measure angle 1. That is substitution property. So statement 4, if measure angle 2 is equals measure angle 3, subtraction property. So we subtract. Therefore, we could say that angle 2 is congruent to angle 3. That is a definition of congruent angle. So we usually say that congruent angles has the same length or measurement. Okay. So here is a paragraph proof. Since angle 1, okay, since angle 2 and angle 1 are complementary, angle 3 and angle 1 are complementary, then by the definition of complementary angles, we have measure angle 2 plus measure angle 1 is equals 90 degrees, and measure angle 3 plus measure angle 1 is 90 degrees. Thus, measure angle 2 plus measure angle 1 is equal to measure angle 3 plus measure angle 3 by substitution. This implies that measure angle 2 and equals to measure angle 3 by substitution property. Therefore, by the definitions of congruent angles, angle 2 is congruent to angle 3. Okay. Okay, let's fill in the blanks to complete the two columns proof of one case of the congruent supplements theorem. So our given angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. Prove angle 1 is congruent to angle 3. Okay, so we have here what first statements of where we can give. So of course, We could say that angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. Of course, the reason is given. Measure angle 1 plus measure angle 2 is equals to 180 degrees, and measure angle 2 plus measure angle 2 is 180 degrees. So these are from the definition of supplementary angles. So what will be the second, we could say that measure angle 2 plus measure angle 3, or measure angle 1 plus measure angle 3 is what do you call this one, 180 degrees. That's from substitution. Okay, so measure angle 2 is equals to measure angle 3. Of course, reflexive property of are equal, no, of equality. Then we could say that measure angle 1 and measure angle 2. So what's the reason? No, so our reason here is from uh, the definition of supplementary angles. Therefore, we could say that angle 1 is congruent to angle 3 by the definitions of congruent angles. Okay? Alright. Yan. Okay, so measure. Right. So these are the answers. Yan. Okay, next. So use the given plan to write a common proof. Okay, so the given angle 1 and supplementary. Okay, plan the definitions of supplementary and congruent angles and substitution to show that measure angle 1 and by supplementary angles. Okay, I should go on. Okay, here. So here are the proofs. Okay, we could say that measure angle 1 and angle 2 are supplementary, and angle 1 is congruent to angle 3. So the reason is given. Measure angle 1 plus measure angle 2 is equals to 180 degrees from the definitions of supplementary angles. Measure angle 1 is equals to measure angle 3, definition of congruent angles. And measure angle 3 plus measure angle 2 is equals to 180 degrees from the substitution property. And of course, measure angle 3 and angle 2 are supplementary from the definition of supplementary angles. All right. So if you have more questions, please, you can, I know you can leave a comment in the comment section. So remember, gratitude is the best attitude. And mathematics is not just about numbers. Much of it is a problem solving and reasoning. Love you all, guys. Merry Christmas, everyone. And of course, to all my teams, Organic Barcanas, Team Solid Family, and YTC International. Thank you so much, Team Foodies. Love you all, guys. And to all my students, my co-teachers, everyone out there, my friends, love you all. Merry Christmas and Happy New Year.